example one. Let me see, do I have a good one? Yeah, this one works great. If I want to solve the absolute value of 5x minus 2 equals 13. Okay, a graphical interpretation of that problem would be if I said y equals that and y equals that. Okay, over here, the graph for this is going to be that V-shaped one, right? And this 5 is minus 2. This, we've had some shifting and some stretching done to this thing. And it's going to look, if you let me do a real quick sketch graph, like it's going to look like that-ish. Okay? That's what that absolute value function is going to look like essentially. Okay? Over here, if I want to do the graph of y equals 13, that's just a constant function. That's a horizontal line, right? Maybe like that. So if I'm looking for the value of x, where this equals this, I can see from the picture that there's two possibilities, right? There's going to be probably some negative x over here maybe, and some other positive x over here somewhere. Okay? So I'm looking for those two solutions. But how do I get them? Okay? Here's the thing. If you're just talking absolute value, if I asked you, what's the absolute value of 8, you'd tell me 8. And if I asked you what's the absolute value of negative 8, you would also tell me. So if I told you the absolute value of something equals 8, isn't there two possibilities?
Negative and positive.
Yeah, right here. I mean, we spelled it out. If I'm taking the absolute value of some number and I'm getting positive 8, inside that absolute value might be the positive 8 itself, but it also might be the negative 8. Okay? So over here when I tell you that 5x minus 2, or the absolute value of 5x minus 2 equals 13, I've got two possibilities for this number, the thing that I'm taking the absolute value of. The 5x minus 2, that might be 13. Because if it equaled 13, then the absolute value of the 13 would still give me the 13, right? Or, the other possibility is when I take the absolute value of that 5x minus 2, whatever that number is, if that number was negative 13, the absolute value of the negative 13 would also give me positive 13, right? Those are my two possibilities, and that's how I solve an absolute value equation. When I get it down to the point where it says absolute value of something equals a number, asterisk, then whatever is inside the absolute value is going to could potentially equal the positive or negative of that number. Okay? And then once I've gotten rid of absolute value, this is now a really easy equation to solve. Right? In fact, it's worth pointing out, what is the only difference between this equation and this equation?
What's positive or negative?
Which number is positive versus negative? That number over there, right? The common mistake I see students try to do is they try to change a sign, but they try to change this sign instead of this sign. Okay, be careful about that. Make sure you're changing essentially the plus or minus of that number right there. All right? So since they are easy linear equations, let's solve them real fast. Let's add 2. So 5x equals 15 divided by 5. And we get, one solution, x equals 3. And even with just a really, really rough sketch graph, does that look like that could have been a 3 right there? Sure. Over here, when I add my 2 and such, I get 5x equals negative 11 divided by 5. I get negative 11 fifths, which is like negative 2.2. And you know, maybe that's not quite negative 2.2 if that's 3 over there, but maybe that wasn't 13 there, maybe 13 was a little higher. Okay? But those are my two solutions. And if I want to, I can check them by plugging them back in, although they should check. Okay, there's no reason why the solutions you get here don't check. If they don't check, it's not that they're not solutions. Well, they're not, but it means you did something wrong. Okay? For the most part. Absolute value of that equals 1. I don't want to do a graph for that. It's got a crazier graph. So when you take pre-calc, you'll talk about the graph of that. But it's like this. Okay. Plan of attack. Absolute value equals a number, right? So whatever I have inside, 3x minus 4 over 2x plus 3, that could equal what? What's one option?
1.
Or the stuff on the inside, 3x minus 4 over 2x plus 3 equals, what's my other option? Negative. And that gives me two equations to solve. They are rational equations. We have fractions, right? But this is simply kind of an easy-ish rational equation. If I'm going to clear fractions and multiply both sides by my lowest common denominator, I'm just multiplying both sides by 2x plus 3, right? And the multiplying and the dividing cancel out right on the left, leaving just the 3x minus 4 equals the 2x plus 3. And you don't know how to solve that, so I'm going to say once you skip a few. What are y'all getting for x?
7.
7? Good news, my notes say 7 too. Okay. On the other side, same thing happens. I multiply both sides by 2x plus 3. Multiplying and dividing cancel. 3x minus 4 equals negative 2x minus 3. This time you're going to get a fraction.
Is it a 1/5?
Yeah, it's 1/5. Were you waiting for somebody else to say it, Martha?
Yeah.
Be bold. Even if you're wrong. People will follow you. 1/5. All of a sudden the answer's a fraction and y'all are like timid about it. Like y'all jumped all over the 7 and you're like, yeah, 7, got it. 1/5 you're like, I don't know. He said it was a fraction, but it's probably wrong. Is that what happened? No, you just don't like talking. I remember, y'all want to make me feel weird at this. Okay. So let's do another one.